All right. Good afternoon, everybody. Welcome to the Indicator Behavior Working Group. My name is Charlie Prick. I'm the chair and host here. I'm from Johns Hopkins Applied Physics Lab, but glad to see everybody here today for the Open Cybersecurity Alliance. We normally like to start these meetings off with a technical talk and then provide some open discussion about some of the current research and areas that our Indicator Behavior Project is heading towards. So at first, for those of you that are new to the group, I'd like to welcome you. We're happy to have you and look forward to some of your discussions and contributions today. And with that said, I thought it would be good to start off with our tech talk this month. We're very lucky to have Xiao Kui with us today from the Kestrel project, who's going to talk to us a little bit about another Open Cybersecurity Alliance project, the Kestrel Threat Hunting Language, that I think you guys will find pretty interesting. During some of the OCA CASP plug fests, we've tested out some ideas of using Kestrel hunt books for detection correlations in indicator behavior bundles. And so I think these are two projects that can work very well together. But with that said, I'd like to hand the microphone over to Xiao Kui. And Xiao Kui, the floor is yours.
Thank you for the introduction, Charles. And it's a pleasure to be here and to meet all the people. I think I already meet some of you guys. So nice to be here. And I will try to talk and make the connection between Kestrel and IOB. And I think there are some things that are very aligned together, and we should work closely together to group the two projects together. So I will give a little bit idea about what Kestrel is, and then to connect it with IOB. Let me see, share screen. Okay, so Kestrel is an OCA project, another OCA project that I think many of you may already heard of. And this is a project for threat hunting. And basically, we are creating a domain-specific language for threat hunters for them to better hunt. So there are two things that we are focusing on when we are facilitating the hunting capability and the hunting flows. One is called composability. That is something that we...
Xiao Kui, if you're advancing slides, they're not moving.
Not yet.
Oh, sorry. Apologies.
Just want to give some very general ideas. So in the current days of threat hunting, people are doing a lot of things just isolatedly. So people are wondering whether they can share the hunts, they can build the hunts on top of previous hunts. And that's a part that we need composability, that if we can reuse some part of the hunt and pieces them together into a new hunt and run them in different environments, that will facilitate the hunting procedure, make it faster, have better productivity for hunters. That's one of the roots about Kestrel, that the way that we are thinking, the why we are creating the project. And from another point of view, we found most of the hunting languages currently on the market are focusing on logs or record. We call it records. It's essentially logs, a line of logs, because this is the way that how data is stored in today's format. However, when threat hunters are thinking about threats, are thinking about attacks, if they are coming from a systematic point of view, they are thinking from threat hypothesis. And then that means in a threat hypothesis, they need to think about what are the actors, what are the actions they take, what are the entities they touched, what's the relation between the entities, and how can we describe what they have done with the entities and relations and things like behaviors that they have. So when we think about behavior, the very first thing we can think about is description of the behavior through entities and relations. This goes beyond line of logs. So in current way of hunting, people need to query logs and then chain or join different type of logs to be able to describe something more abstract, like a behavior, like a relation between entities. And Kestrel tried to have an abstraction layer ready for the users, for the hunters to do that. That aligns very well with IOB project, I believe. So that I will give some ideas then. So basically, those two are two thoughts. Let me quickly summarize again. The first thought for Kestrel, that why we are doing it, is we think the industry need a composable way of reusing the knowledge, sharing the knowledge, so that can facilitate the hunters to hunt faster with more productivity. Second thing is the current log-based way is too detailed, too concrete. And we may need something more abstract for people to quickly write what is IOB, what is not only IOB, but the entire campaign, how to navigate through the campaign, do the investigation and things. We need something more abstract than the logs to make it faster. So that's where you see the Kestrel project is. So the traditionally in the detection space, when people are doing detection or hunting, they comes from the bottom parts, the easiest part. If they have IOCs already matched to the more abstract part on the top, many of the hunters we met today from different companies, they label TTP as a very tough job for them because they need to read the threat hypothesis. They need to think about what is a procedure for a technique, and they need to translate that into a specific query language they need to have against a specific data source. And they also need to think about the query, the data source may have different type of logs. They need to correlate or chain things together or join things together. How to write a query for that. And that's for a single TTP, usually. And when they're trying to match something more than a single TTP, that's more complicated. They need to send a first query and get the result back, may use some Python script or some other shell script to process it, extract the information they need, and craft a second query based on the information from the first query and threat intelligence, and then to send the second query to the data source. When they want to chain multiple TTPs to detect the entire campaign, that's not easy. So if we think about threat hunting as a discovery of entire campaign or multiple TTPs at least, then we need something more automatic. This is not an automatic, intelligent to detect everything, but running in a way that has less human intervention, so that we can pipe everything together to run everything one step after another, to talk to a data source, get data back, and followed by some other steps, automatically executed. Depending on what we get back, we need to follow the third or the fourth step, or maybe another branch. This is something that we try to do in Kestrel. So Kestrel wants to make threat hunting easier for people. That's the basic idea. And the way we do it is provide people a layer of abstraction. The layer of the abstraction is a new language. We call it a high-level language for threat hunting. Yeah. And some of the simple tasks that people are usually doing. First one for hunting or investigation is they need to get the dots. And the second thing is they need to connect the dots. The third thing is they need to automate. And the first thing about the dots, some of the dots are very simple IOCs. Some of the dots are more complicated and like IOBs. I think the IOB project also is going into how to describe IOBs, for example, in 6 patterns or in some other higher level descriptions, so that people will be able to match that. And from the view of Kestrel, what we are doing is, of course, we also have some ideas about how to define IOB in 6 pattern, and going beyond, we will have other kind of sub languages to describe IOBs. But another big portion of Kestrel is not only describe it, but also make it actionable. How to match IOBs against the data source. That involves a lot of translation and execution and data normalization. What is the internal data model we can use across different data sources, and how are we going to make everything happen and get rid of the ETLs between different steps. So that's what we call the runtime of Kestrel is doing, or the compiler of the language is doing. And then after people match the TDPs, they may use the same language like a sticks pattern to describe. So in Kestrel, we can wrap a sticks pattern into a Kestrel get command so that you can put the results into a Kestrel variable that you can refer to in the following steps that you can do. We try to provide a normalized or standardized way of doing that so that it can run through different EDR or CM systems and it run in different hunts. And in the current phase, we leverage StickShifter for most of the normalization and standardization thing. StickShifter already have about 30 different connectors to different data sources that people can use. They are not perfect. There are mappings need to be improved, but it's a foundation that people can fine tune and try to connect and do it. So this is about the individual suspicious events or behaviors. I call them dots. And after dots, when people have them, important thing is we want to do false positive elimination. There are attacks that you see a procedure implemented, but then maybe the attacker cannot proceed. Maybe they just penetrate into a system, but they do not find any further steps. They just hung there. And even they do exploits. Some of the exploits may fail. Some of the exploits may succeed. We see so many failed attacks from DARPA-TC when we are monitoring attackers doing attack live and things. More than 50 of them fail. So once we detect a dot, that does not mean this is a full-fledged attack. This is not a full-fledged threat. We need to get more ideas around it in the problems graph. We need to do backtracking to find the root cause of it. We need to do forward tracking to analyze the impact of these dots. And by doing backward forward tracking and by connecting different dots, for example, if we see there is penetration into an endpoint, and then we can follow the penetration through its lateral movement to another endpoint to see what other malicious activity have done there on the other endpoint. This is from process, maybe to another process, and then to a network flow, and then cross the network to another endpoint monitored, and to a process there, to files on another endpoint and things and so on. We can do this type of data flow tracking and control flow tracking in Kestrel easily. By doing so, the problems graph working and backward and forward tracking, we will be able to eliminate a lot of false positives. A lot of things, we may open a ticket, but the ticket may finally be just resolved without anything. And this is because it could be a false positive. It could be something that is not very suspicious, something that is okay to automatically mitigate, or something that we really need to take human attention and try to design very sophisticated detection mechanism, mitigation mechanism. So I call it the threat hypothesis development phase. And this is a phase we try to do a lot of reasoning around the dots to connect them, to expand them, and to find the threat hypothesis around the entire threat, not only a TTP or IOB. And in the third phase, when we have handbooks about either individual TTPs or maybe some threads that compose of multiple TTPs, we will be able to rerun them, to rehunt, or to even feed parameters to these handbooks and to execute them in an automatic manner. So that is something that we have some progress with OpenC2 community. And last month, I think we released the public OpenC2 hunting profile, and that's built on top of the Kestrel definition. And you can easily use the OpenC2 investigate command now. It's a standard formal command, official command, to invoke a Kestrel handbook with parameters. And I will show some of the examples then. Okay, in summary, this is something that hopefully I make some connection with IOBs, and also how we facilitate and push beyond just describing IOB, but also how to make it actionable and how to connect them together when a threat hunter is thinking about threat hypotheses around the campaign and things. Yeah. So next, I will show some live demos that we developed for Black Hat 22 and 2022. And then before that, I will take any questions if anyone has questions about a high-level idea before we go into some of the examples here.
I had one question, Xiaokui, that I was thinking of as I was listening to you describe the whole process. Has anyone on Kestrel been looking at potentially a translation between a hunt book and a Cacao workflow, or is that a little bit too separate right now?
I think the current understanding is we will embed a Kestrel hunt flow into a step of a Cacao playbook. So Cacao playbook is more general, that it can invoke any detection, any response, any of the maybe escalation or any of the things. And Kestrel is focused on hunting or investigation. So that's the part that this is something very open, but the current thought is we can embed a Kestrel hunt flow or hunt book as a Cacao playbook stack. So yeah, that's the current thought. You can, that means you can orchestrate more than just hunting through a Cacao playbook. Yeah.
Thank you.
Okay, so there are 4 things I'm happy to show today, and actually this is something that I will show how you can play with yourself, and this is everything is public. We released open source everything, even the lab. So the first is around how to describe a TTP. I think this relates very well with IOB project, and Charles has some of the description of IOBs in Stix pattern as well. We can try them out in Kestrel, since Kestrel supports Stix pattern as part of its syntax. And this is something I will show them first. And then this is the second part, is connecting the dots, is how are we going to think about the entire campaign composed of multiple TTPs. And third one is to run existing analytics, like enrichment. If you have some IP addresses, you want to check whether they are malicious, or no malicious IP address in VirusTotal, you want to check it against IBM X-Force Exchange, and we have open source analytics for them, and so that you can do. Also, there are virtualizations here, and enrichment, virtualization, and also any detection, complicated detection tool like anomaly detection from some machine learning or AI tools, or even some LLM tools that we can wrap around into a Kestrel analytics to help you to better hunt. So those are the things we can easily plug in through Kestrel analytics. I can show easily. And fourth one is about how to use Kestrel in an OpenC2 context, and then to automatically run Kestrel hunt book through OpenC2 investigate command. So this is something that we just released official standard for that a month ago, as I mentioned. Yeah. Anything someone wants to focus more, or I just go through them? Okay, then.
Can you hear me?
Yeah, please.
Yeah, I'll just point out to everyone here that there is a draft actuator profile for threat hunting on the OpenC2 GitHub site, but it really needs additional eyes. We still need a number of different definitions for the hunt. We need some critical evaluation of the actuator profile. So I invite all of you, if you're not a member of the OpenC2 technical committee, please join and take a look at that actuator profile and help us improve it.
Thank you, Jen. Yeah, this is really helpful message. And I think some OpenC2 community people are also working with us about setting up a demo about how to show the value of the hunting profile, how to trigger it through different geolocations, and how to make it kind of actionable and automatic running across different companies and things. Those are the things that we are happy to take any advice or any comments from the community, and anyone who has any ideas about the use case or anything that can help us prepare the demo, that will be very, very helpful. Okay. So let me share my screen about the okay. So could you see my Chrome? Okay, so this is a Kestrel repository. I think people here should be familiar with under Open Cybersecurity Alliance, and we put some of the most critical links. This is not only a repository, but it acts like a portal for the Kestrel project. So we have all the important links that you need to check for all the tutorials, all the blogs, all the demos and videos, and we have here. So most of the information you can find through this portal. So basically, the thing I want to show is some handbooks we developed for Black Hat 2022 for the 4 handbooks. And this is a binder service that we start a Kestrel environment with all the Kestrel compiler runtime in a container in the public cloud. And talking to some clients, especially some very big enterprise clients, they like the way that how the hunt is kind of started in this way. So we are building another sub-project from Kestrel to enable people to just do similar things as this binder service. This is a public cloud service that you can host the containers about the Kestrel containers, run all the things about Kestrel. People are also thinking about running that in private cloud for very big enterprise for their hunting. So that's where we have the Kestrel as a service repository, and we are going to make announcements, make OC blogs, and also some Red Hat articles about it. It's the Red Hat people who are helping here to help us to get the thing into containerized Kubernetes-based services that enterprise can spin up. It's very elastic, so that as many hunters as you want, you can spin up different containers for Kestrel, hunt there, and share the handbooks in the same repository, and even work with each other's hunt sessions. Okay, so let me go back to Kestrel-LAN, and here's the container that's the Jupyter Notebook already opened. So the first one we are going to show is about TTPs. Let me give a little bit maybe background. Okay, I think it's fine to just go from here. So there are a few things we're going to hunt. There are 3 hosts monitored here. This is a Windows host that's monitored by Sysmon, and we have all the data from Sysmon that's going into Elasticsearch. And the second machine is also a Windows machine. We have Sysmon running there, and all the data is going to Elasticsearch. Third one is a Linux box that we have a Sysflow running there, and the System Monitor, and then all the data is going to Elasticsearch as well. So most of the data sources here we are querying is in Elasticsearch, different indexes that we can query them. And the first thing we're going to test is, can we match some of the TTPs by the description? So we did some of the tags using Caldera, and so in Caldera, the attacker can see what exactly the attack tool is doing for each of the steps. For example, for this find user process activity, it uses this PowerShell script to list the name of the users. And if we know the attack procedure, like in these details, this is something that people usually get from strategy reports. And then they can craft a IOB pattern like this. This is for TTP find user process. And this is a very simple IOB pattern similar to IOC, but it's still IOB because it's not a hash or something IP address. It has a little bit kind of wildcard, even not regular expression. We can execute this and to find any of the process that has this name and has this command line. This is a very weak container, so the execution is slow, but let's see. Yeah, it gets back two processes, PowerShell processes. Actually, it's the same one. But because some of the records do not have command lines, so Castro cannot just combine them in case there are different command lines at different processes. But basically, this is the process with the command line listed that we can get back. This is a very simple single hunt step hunt flow. So Castro hunt flow is much more complicated most of the time, but this is a very simple one that people can try. Something a little bit more complicated, they can find a command line that contains some of the other strings that usually indicators of other attack, of other technique as a TTPs. And this is very simple. You just do similar things as what described here, and you get back some PowerShells that has this in the command line. Okay, so can we do a little bit more abstraction? And for example, there are two TTP, T5070 and T1021. And both of them are about letter movement, but they are different steps in letter movement. They share very similar things that they both use the Windows management to go forward to another machine. One of them is just to try to connect the first one. The another one, the one of them is SCP, just to copy the data, to copy the binary. Second one is to start a new process or remotely. So they share a lot of things in common, and we can just make a little bit abstraction and match something like any of the process from the two steps of letter movement. So you can see this is the first step of letter movement. This is the second step that start a new process. Things they have things in common so that we can write the IOB pattern to match both of them. It's still very simple. This is a little bit more complicated. I think this is something that kind of more likely the one that threat hunters are doing TTP pattern matching from daily to daily. This is a pattern that there's a process for another process that is not associated with the binary of the first process. There are two realizations for this. First one is on Windows machine. For example, this one. There may be an email process that forks some other processes. We will see what other processes are. That is not Windows, the email process. This indicates maybe something. Oh, this is a browser. So that's common. So sometimes people click a link in the email and start a browser from an email client. That's good. But sometimes you see this. That is suspicious. So this is something that we try to match and try to detect. Of course, you can have a follow-up Castro steps I will show in the second handbook to filter this out and then to do further investigation then. And another way to interpret it is, for example, on a Linux machine, you can have Nginx, Node.js, or maybe Apache web services. Those web services usually have worker node, worker processes forked when they handle a network connection. But if it forked a shell, a Python, a bash or something, then that indicates something may gone wrong. Maybe there is exploit. Of course, another indicator I think Charles showed before is about the user change, privilege escalation. When there is maybe previously it's a normal user or www user associated with it, and later on we see a root associated with it. That's another thing that we can think about. So after we match these, the very similar pattern, you can see it's nearly the same, but just this string is different. Remember this, we will see this example again in the automation part so that we can use the same handbook to do the two things, just given different parameters. So this one actually is a Node.js process that fork a Splunk process, which is a Cadera agent. So the Splunk did a lot of things like this one. Yeah, this is how the Splunk is forked. Okay, and this is the first handbook. And let me go to the second one. Any questions for the first one? Okay, so the first one is about individual TTP or behavior we try to match. And the second one is about how can we do more investigation around each of them. For example, this is the behavior that we found, that there may be some email clients that forks not only browsers, but also CMD. That's very suspicious. Can we just get the CMDs and to do further investigation? Yeah, we can just get the PID here. So all the name, that's fine. We can also do name equals that, that's fine. And then when we get the processes, this is the two records we have from all the records we matched. We have 26 records, and these are about 9 records. We get 9 line of logs about this CMD, about the CMPID, and then we can just doing more by connecting different type of Kestrel commands other than get. So previously we just used get in the demo, and we just filtered a little bit. And let's use another command, Kestrel command called find. Find is the one that we can resolve relations between different entities. For example, we have processes in the Kestrel work or CMD. We want to get its child process. We want to get its network traffic. We want to get all the files attached to do further investigation. That's where you use a command find. And this is a figure that will help you to pick up the syntax to write find, depending on what is the return and what is the input you give it. For example, if we want to find child processes, this is from process to, we want to get child process to process. So we want to find process, use a keyword created by, and then the input variable. So find process, use this keyword created by, and the variable we have that contains all the entities or processes we derived there. And then this one, we get several of them. Some of them are PowerShell, some of them just Windows kind of services con host. This is not enough. And we can further do it by looking for the same process at a larger scope. Or we can find even a child process of the CMD activities. So CMD activities is a child process of CMD, and the PowerShell activities is actually a child process of CMD activities, since it's nested that the email client forks CMD, the CMD forks PowerShell, so that we want to get the PowerShell activities that we finally get some process like Splunkd, which is a Cadera agent. And we can go further to see that what's the Cadera agent doing, that the Cadera agent Splunkd actually do a lot of things. It launches, for example, letter movement to another Windows machine and to a Linux machine. This is a letter movement through, let me see which one. This, let me see which is the Linux one. Okay. There should be, we will see later. Yeah, I will check following that we have some of the processes to check the Linux one. So one of the, so when we list all the child processes from Splunkd, we will find that the attacker did some of the check about antivirus, attacker did list some of the, this is to edit some of the user side permissions and things, and maybe do something else, like do letter movement. Let me check. This is letter movement to a Linux machine, looks like, using an exploit of the Linux machine. So we may follow this. And another thing is we also see a letter movement to a Windows machine, I think, that PS new session, start a new session on this machine. So we can follow these two processes individually and to get their network connection and to follow their network flow to their target machine. If the target machine is also monitored, we can get more information from on other side to see how the thread progress there. So we already checked the first Windows machine and get some malicious activity there. Next, we figure out there are two processes, 16 and 7028. 7028, this is the Windows one. And these two are Windows ones that goes into the Windows machine. We may want to follow it to see how it goes to another Windows machine. And then there is a Linux machine we also want to later on we want to follow. So basically we do the same thing like filter the PID to have a less list of processes there, and then to find the network traffic created by it and follow the network traffic to the Windows machine that we monitor. So this time we query the Windows machine, and then to list the network traffic on the Windows machine side. Even though you will see the network traffic is the same, but actually they are monitored by two different monitors on two different hosts. So they are same. That's good because they are the two ends of the network traffic. And then from the traffic, we can move to which process on the Windows machine that creates this traffic, that handles the traffic. And even we can match other things like Splunk on the Windows machine to see what are the activities the second Windows machine was doing after that movement. And I will skip most of the things here that you can check the handbooks after the session. So this is a attempt to follow the lateral movement to the Linux machine through the exploit. So basically we do the same thing that checks the network traffic to the Linux machine and then query the Linux machine, get the network traffic on the Linux machine side, and then find the process that creates the network traffic on the Linux machine. Now everything is Linux. And then we can also find all the activities as the child processes of the process that creates a Linux that works on the Linux machine. And then we can see a lot of activities there. It's maybe too many to handle for human eye to quickly pick up which one is malicious and what does it mean by those of them. So then we need something.
Hey, Xiaokui?
Yeah, please.
We'll probably need to wrap up in about 5 minutes, if that's okay.
Okay, sure. Let me give an idea about what a third and fourth handbook look like, and then we wrap up. So we get a lot of results here that we need some way to quickly summarize them to pick up the ones that may be suspicious. So we can launch analytics to filter out some of the traffic and to add some new, enrich with some new attributes like domain name lookup, visualize them, and then even launch some of the statistical analysis or the machine learning tools through analytics. And that's about the third handbook. That's we have more than 10 analytics open source currently in the Kestrel Analytics repo that you can check. And the fourth one is a Python notebook. It's not a Kestrel one. So this is the one that we use OpenC2 to launch a Kestrel Handflow. The Kestrel Handflow is actually this one, the first one that we checked at the bottom of it. So there are two versions of it. One is the email version, the one is node version. And we execute the two here. This one is the node version, this one is the email version by different parameters given to it and gets the result back. Okay, so this is about the 4 handbooks, and let me wrap up. Okay, so Kestrel, as I shown here, is a way that you chain multiple hunting steps like a pattern matching, IOCIV pattern matching analytics into a Handflow. So it's a composable way of writing handbooks that can be executed against the data source and things and so on. And this is the illustration of what a handbook look like when you have variables as a V and HS is the hunt step. And lastly, let me show this one. Okay. So as I mentioned, every piece of information can be found on the Kestrel Lang repo. And through the Kestrel Lang repo, there are links to our documentation that we have the language specification, how to run it, how to debug it, how to install it, how to configure stick shifter parts. And we have the Kestrel Handbook repo that hosts the community contributed Kestrel Handbook. There are not many currently, and we are still trying to bootstrap this for the community. And then the demo I just showed you is something that you can easily click and run your own version. And then we also have Kestrel blogs that we post for people to get an idea how to write some of the Kestrel Handbook, write analytics and things and so on. Okay, that's all about these technical parts.
Oh. First of all, thank you so much. That was a fantastic demonstration and overview of the language. I wanted to see if any of our members had any questions for Jacques regarding Kestrel. We have a few minutes. We can entertain some additional QA if anyone has them. All right. I'm just scanning the chat as well. Okay. Well, in that case, I thank you tremendously again, sir. And do want to take a few minutes of our time together this month to just share some additional updates on the IOB project with the group. As I mentioned at our last meeting, Kurt, my partner in crime at APL, has been working with his team on building out some new examples. We're beginning to design out a additional threat scenario that we'd like to model based on a more of a wiperware style attack, as well as we're hoping it might take us till the new year to be able to demo it, but we're also working on some improvements on the Stix modeler project to give us a graphical user interface for building behavior bundles as well as any other Stix bundle, just because we know that for our team, a lot of folks can build these out programmatically or through a tip, but that's still a barrier for certain analysts who don't program. So we want to show some proof of concept and early prototype capability to make that more accessible to folks that wish to create their own behavior bundles. Additionally, in December, IOB will be participating in the next CASP Plug Fest. Jane is an active member on CASP, as I know is Vasilios and a few other folks here. But we'll be looking at ways for things like Kestrel and Cacao and OpenC2 and IOB to work together to enhance a certain defense scenario. This is a lot of prep work to get us towards a much larger Plugfest in March. I want to say March 16th, if that sounds right, Jane. I think, I'll be honest,
it's a half day. It'll be a half day on the 13th. That'll be the setup day. That's Wednesday, March 13th. And then 2 full days, the 14th and 15th, Thursday and Friday.
I was close, but yes, 13th through 15th. But there'll be a large in-person Plug Fest, I believe, in Northern Virginia. So that'll be a great opportunity to have us start bringing all these standardized capabilities together and get some really awesome demonstrations of capability. Additionally, Xiao Kui and I have been speaking rather frequently on many Zoom meetings as we are also refining the Stix extensions for SDOs and SEOs across all the OCA projects. And on our call that's coming up Monday, we're going to continue that as we want to make sure that we have common representation of extensions, especially for the observables. And just that's coming along. And I am happy to entertain any additional questions, comments, or concerns anybody might have for what we're doing with the IOB project. So I'll open the floor for a moment. Okie dokie. Then I will always take awkward silence as everybody is fully behind us and super supportive, and I'm grateful for that. And I will thank all of you for giving us your time today. And I will send out the meeting minutes as well as the recording in a couple of days once I have those all correlated. And then we will still get together in December, where I believe Vasilios will be sharing some really cool research that he's been up to. So I just thank you all again, and I will stop the recording now.